Welcome back to the channel. In this video I'm going to talk about radio equipment testing for electromagnetic compatibility and other standards, and more specifically I'm going to talk about integrating into your product a printed circuit board like this one with an off-the-shelf LTE modem. Manufacturers frequently assume that when you pick an off-the-shelf modem you don't need to do any testing. To some degree that is true, but only under specific circumstances, and today I'm going to describe them. Let's begin from bare basics of radio equipment compliance worldwide. First of all, we have to think about two regions that create standards for radio equipment compliance, and those are Europe and United States. The standards are typically different between those two regions, but everywhere else in the world, they are likely to follow and fall under the same categories. So for Europe, we have this global thing called CE compliance, which is resulting in the issue of the CE mark. And specifically for radio equipment, we have Radio Equipment Directive 2014/53/EU. And this directive defines exactly the testing of so-called intentional radiators. And the intentional radiator, in this example, is something that actively transmits and receives radio signals. So it has a channel. An example of that would be a Wi-Fi router or a Bluetooth device or a mobile phone. Whereas anything else that does not integrate active transmitters would be considered as unintentional radiator, and instead it will fall under EMC directive. Being compliant with Radio Equipment Directive does not mean that you automatically comply with EMC directive as well. Typically you do have to prove compliance to both, but Radio Equipment Directive standards tend to reference EMC directive standards. Now the second region is United States, and in this region we've got Federal Communications Committee. Now FCC requires that all intentional radiators must be issued with identification number. And if we look closely on this PCB from Telit here, it has been already issued with FCC identification number. You can see it written there. So in that case, we can do limited amount of testing when we integrate this product into our product. The first major difference for the testing that we do for intentional radiators versus unintentional radiators is that under Radio Equipment Directive Article 3.1a, intentional radiators will always require testing in accordance with low voltage directive as well, whereas unintentional radiators can be exempt from low voltage directive if their voltage supply is less than 75 volts DC or 50 volts AC. So that practically means that the EN 62368-1 standard will always apply to radio equipment such as this one, even if the voltage supply is only 5 volts, which is the case for VBus. Then the second major difference for intentional radiators is that they must be tested for total radiating power, total isotropic sensitivity, spurious emissions, occupied bandwidth, as well as specific absorption rate when it applies. However, in this case, this module has already been tested for those things, and that is confirmed with its FCC identification number, then we do not have to do those tests, but we must install this module in accordance with manufacturer's guidelines if we want to comply with Radio Equipment Directive and FCC Part 15. What it practically means is that when you install it in your product, you must use the exact same antenna that has been used during the radio equipment test, and you must also use the exact same cable length. Either of those things can prove difficult, and very frequently the manufacturer is not able to meet this requirement because the antenna could be completely unsuitable for the product. Sometimes you can assume the compatibility when you're using an antenna with very similar specifications in terms of its gain and radiating performance. However, this is something of a gray area, whereas if you definitely want to be compliant, you may want to do some testing. And this kind of testing you absolutely have to do when you're using a different antenna. For example, if the FCC test has been performed with a monopole antenna, and you cannot use monopole antenna in your product, instead you're using a patch antenna, then you have to do some testing. Now let's talk about this testing. And in European Union, this type of testing is regulated by European Telecommunication Standards Institute, which is abbreviated as ETSI. The standards that are published by ETSI are typically also internationally recognized and apply in many other countries outside of European Union, for example in UK. The main standard that you need to consider when you integrate this kind of a module into your product is ETSI EN 301-489-52, and that considers emissions and immunity testing for radio products. Also, in accordance with ETSI EG 203367, you must test radio equipment in two modes of operation for immunity and one mode of operation for emissions. And the two modes that you are typically considering would be wireless traffic mode. In other words, the transmitter is actively transmitting data to the device, which could be the mobile phone. And the second mode of operation is the idle mode. In other words, the transmitter is in standby. Then for EMC scan, this standard references CISPR 22, which you should be familiar with as it specifies classes of operation for A and B scenarios, which would be residential and industrial environments. And it has the compliance limit for quasi-peak and average values of the emissions. When performing the measurement to CISPR 22 limits, you do not have to transmit and receive active data from this device, but you could just place it in the idle mode. However, you cannot switch it off. Then when you're doing immunity, things getting a little bit more complicated. For example, when you're applying an ESD gun, you have to do it in two scenarios. First, where you're actively transmitting data, and second, when it's stationary and operates in idle mode. Obviously, in that case, when you're operating it in an active traffic mode, you will be monitoring the quality of signal. And if you experience any performance degradation, such as a dropout in the signal transmission, that would typically classify as a failure. Finally, the second major standard that we need to apply in this case is ETSI EN 301-908-1 V15, and this standard specifies radiated spurious emissions limits. The spurious emissions are basically any out-of-band emissions created by the signal transmission in the active transmission mode. So this testing is slightly different to EMC testing against CISPR22 limits, as you need to consider reflections and harmonics that may arise just by integrating this module into your product, because, for example, it could have a metal case and there could be reflections coming from this metal case that create spurious emissions. And this is why this testing is required regardless of whether or not the module has been certified previously. So to summarize, when you integrate a pre-certified module into your product, in European Union, there are two main standards that you need to consider. Those specify your EMC, immunity, and spurious emissions testing that you need to check against before you can put your device into full production. Additionally, you must also check for electrical safety of this product in accordance with Low Voltage Directive, which typically specifies EN 62368-1 standard for multimedia equipment. In the United States, the picture is rather similar, whereas the electrical safety testing is also always required for radio equipment. And that typically means testing to one of the UL standards, which is one of the nationally recognized testing laboratories in the United States. There are others, such as Intertech or MET Labs, DECRA, TUV, and so on, but those bodies typically don't issue standards, whereas UL, that stands for Underwriters Laboratory, also issues its own standards, and UL has its own 62368-1 standard, which is slightly different to the European version. Needless to say, in order to comply with UL, you cannot just simply pull out your CE certificate. CE certification does not work in the US. And it is a requirement by the Occupational Safety and Health Administration that all radio equipment devices to be sold in the United States must be certified by one of the nationally recognized testing laboratories. The only exception to this rule is if the product has been issued with a CB mark. And a CB mark is a different kind of internationally recognized marking scheme that also references 62368-1, but is supposed to ease the integration of products worldwide. However, not every distributor of electronic product will accept CB mark, and many distributors in the United States will still require you to do testing in one of the NRTL laboratories. In the end, it all kind of boils down to the insurance policy that the distributor of electronic equipment is following, whereas the equipment standards are practically the same. Similar situation also applies in Canada, where we have a CAN logo, and the CAN logo references CSA-C22.2 standard. However, aside of those electrical safety tests, there's no more testing typically required for radio modules that have already been issued an FCC identifier in the United States. So there is no spurious emissions test, and the usual EMC limits will apply under FCC Part 1547. Now that's it for the equipment that has already been issued with an FCC identifier and has been tested for radio equipment directive under CE logo. Now let's briefly also discuss the situation for intentional radiators that do not have an FCC identifier or have not been tested against CE marking. And What happens then if you just buy some module from Alibaba and it does not have an FCC identifier on it? So, in Europe, we have several ETSI standards that regulate the active transmitting devices depending on their operating frequencies within their occupied bandwidth. Those standards consider active transmitter as a short-range device, or SRD, and that is the legal term for it. And the kind of tests that you will need to do in order to comply with one of those standards would include the duty cycle check, occupied bandwidth check, spurious emissions check, as well as the transmit power and receive sensitivity. On top of that, ETSI also issues some specialized standards for Wi-Fi, for example, and that would be EN 300 328 v2.2.2. That also applies to Bluetooth and Zigbee. In other words, those all devices operating at 2.4 GHz. And also, there is a standard for RFID that operates at 13.56 MHz, and that is ETSI EN 302 291-1v.1.1.1. So under those specialized standards, there will be additional tests and requirements that apply to such devices. Finally, if it's a device such as a mobile phone and it is to be used within 30 centimeters in its normal function from a human body or head, such as like this, then a specific absorption rates testing will also apply, and that is regulated by EN 62311/2019. Specific absorption rate test is particularly difficult to perform and is extremely expensive, as it requires a model of a human body placed inside an anechoic chamber, and the performance of radio equipment needs to be evaluated in a sphere. So a fairly similar scenario will also apply in the United States, where you have to basically obtain the FCC identification number, and to do that you will also have to do all those tests. The standards that are referenced by FCC Part 1547 are not the ETSI standards, but instead they would be the ANSI standards, which stands for American National Standards Institute. Unlike ETSI standards, ANSI standards are not publicly available, and you have to pay a hefty fee in order to read them. Additionally, when you have to place an active transmitter on a network, which would be the case for this device since it's an LTE module, then you must also comply with the strict requirements of network operators in the US, and particularly with the network operator of your choice. Each network operator, such as T-Mobile, Verizon, and so on, will have its own set of requirements for the devices that are to be added to their network, and they will also evaluate TRP, TIS, and spurious emissions. Additionally, they will also evaluate how does the device respond to specific circumstances, so they will typically ask you to provide them a device with fully finished software, and then they're gonna test it under different network operating conditions or operating conditions in general to make sure that it satisfies their requirements. And then they will also maintain this device and keep it in their basically shelf, and they will also ask you to provide them with a copy of firmware every time you update it. Some standardization efforts have recently been introduced to the United States, where the network operators came up with something called PTCRB certification. That supposed to allow easy integration of products into networks, which means that if you comply with PTCRB, then you should be compliant with the requirements for each network operator. And the type of tests that are typically required to obtain PTCRB certification typically include evaluation of total radiating power, total isotropic sensitivity, spurious emissions, and SIM card electrical performance. All of this is basically aiming to ensure that your device that would be using this module is not going to look bad on the network, and that it's not going to create interference to other devices. Typically, network operators in Europe do not require or go to such lengths to prove this compliance, and usually refer to ETSI standards to do this job. In some other countries, similar radio equipment requirements exist for active transmitters placed on a network, and those include ISED certification in Canada and Radio Law Article 38 in Japan. To summarize, the testing of radio equipment can be really difficult when it's not pre-certified as a module, and it can become even more difficult when it needs to be placed on a network. So if you're thinking of adding a radio feature to your product, such as Wi-Fi or Bluetooth or an LTE module, then always try to select something that is already compliant with as many standards as possible, and ideally has an FCC identification number written on it, and that will greatly simplify the amount of testing that you need to do as a manufacturer of this equipment. If you're doing something bespoke and you absolutely cannot implement a pre-certified module into your product, or you really have a very strict cost target, then obviously you will have to comply with all the standards listed in the slides. But by all means, feel free to drop me a message, and I can have a look and evaluate the kind of standards you would apply to your product. Anyway, many thanks for watching this video. I hope you found it useful and enjoyable, and please subscribe and like this channel, as I will be releasing more videos related to radio equipment soon. Bye for now!